about right. So who's not here? Just John?
John.
Oh, got that down. Let's see what the book says exactly. What functions? Is anybody looking at that? As the book says, only because I have nothing better. A function is a mathematical rule. I think it says rule, does it not say rule? That shows a relationship. Speaking of dates.
Hey, John's here.
For all intents and purposes, John, how are you? What did the doc say?
I can't put it in.
Really? Congratulations. A mathematical rule that shows a relationship, you know, we've really done this before. It's very similar to basically a formula. I'm not sure who the people are that invented the way this whole math thing shakes down, but I'm not a... They're probably so much smarter than I that it just doesn't make any sense. But one way to think about a function is think about what we like to call a function machine. There is no such thing, but it looks like this. Here you've got your little thing here. I think you'll like this. Good thing you learned how to draw yesterday.
Oh, is it a camera?
What's that?
It looks like a camera.
It's a function.
Oh, it's a little,
I can do
see, it's got a little funnel going in.
that.
And what happens here is you have the numbers that you put in are input numbers. They get stuck into this thing here. And then something happens to transform them. Let's say this is our little transforming formula here. We take this and we x plus 2, and then we have this thing spit out our output number. Now you will recognize this because we've done stuff like this. It's a little like this. Y equals x plus 2, where our input numbers you get to pick. So let's say we put what in there? Let's say we put a 3 in there. What happens if we put a 3 in there, you ask? Well, that little 3, that little 3, he gets right there. Oh, well, there's the 3. That little 3 goes right there. He gets added to 2, and guess what gets spit out? A 5. You're only through the miracle of mathematics. Or if you put a 0 as your input number, you end up with a 2. Or if you see we've already kind of done this before, but they want you to get used to that word function. Instead of using formula, instead of using rule, did I do something wrong?
No, I just don't know how to get
How I got 3? Here, pick a number.
12.
Okay, guess how I got 12?
Your brain.
Yeah, you picked it. And then 12 plus 2 equals, I mean, it could be something like number of hours you work times something right there, but that's not it. But the book likes you to think about a function. Now, there are some things that aren't functions. I don't know if we get to those here or not. Let me look and see. Well, here's it. All they're going to ask you is this. They're going to say stuff like this. They're going to say graph this function. And they will give you an example. For example, y equals 1/2 x minus 2. How am I going to go about graphing that? I'll rewrite it here so I have more room. Well, in order to do that, you are going to, instead of doing the whole function machine, you are just going to create a table. And as Soph went through, how do I know what numbers I'm going to put in for x, Soph?
Brain.
You are just going to come up with them yourself. Now, because you get to come up with them yourself, Zachary, Pick the easiest numbers possible for that.
1.
1 would not be the easiest number possible for that.
Oh,
Why? Because you're taking half of it. Half of 1 is half, but to add half minus 1 minus 2. What would be, Lauren Ulrich, the logical thing I would put in for the numbers for x that would make your life as easy as humanly possible?
4.
Yeah, probably higher even numbers, because you take high even numbers and then you subtract 2 from it. So let's go with, well, let's do 0 first, because 0 is always an easy number. And then Lauren said 4. How about we go with 6 and maybe
8.
Sure, 8. How am I going to find my y numbers? Well, there's no easy way about this. You just have to do it. If you take 0 in for x, what is 1/2 times 0? Anybody?
0.
Minus 2?
Negative.
Negative 2. What is 1/2 of 4? 2. What's 2 minus 2? 0. What's 1/2 of 6?
3.
3 minus 2 is? What? 1. What is 1/2 of 8?
4.
And 4 minus 2 is?
2.
2. Now, once you have to do at least 3, children. Anybody know why you have to do at least 3?
So you can find the one that looks best.
Because notice it said to graph this. This is not a graph, this is a table. But you need your table to make a graph, because these are the ordered pairs that you'll use for your graph. We have 0, negative 2 as an ordered pair, 4, 0, 6, 1, and 8, 2. And fortunately for you, on your homework paper, it's a whole series of grids. So making a graph, have we graphed things before? We've graphed before. We haven't. You can make your x and y coordinates here, right? Where is 0, negative 2? Here's 0, negative 2. Where is 4, 0? 1, 2, 3, 4, 0. Where is 6, 1? 5, 6, 1. And 8, 2 would be 7, 8, 1, 2. And this, ladies and gentlemen, will end up being, what you ask? A nice straight line. And what does that line represent? Somebody asked, Connor, what does that line represent? What good is that line? What does it do for me? By the way, it's the line of y equals 1/2 x minus 2. So if that line is,
It shows that you actually follow the directions.
well, it does, but that's not what it's all about. Anybody know what that line is? Children, that line is all of the possible answers you get from this equation. Alright? In other words, if I put negative 1 in for x, which I wouldn't do because it's hard, half of negative 1 is negative half, and negative half minus 2 is negative 2.5. Guess where this would cross? Right here at negative 2.5. That's another answer for this. If I went all the way to, well, if I went to 2, which I didn't do. If I put 2 in my little function machine, no, I did 2. Wait, did I? No, I didn't do 2. Half of 2 is,
1.
and what's 1 minus 2? Guess what? Here at 1, if I put 1 in for x, guess what I get? Negative 1 there. I missed a little bit, but mine's not perfect. This line stands for every possible answer to this equation. That's why the arrows keep on going for every unit drawn, but that's what's there. And the reason you have to do 3 points,
So it's going to make a line.
no, 2 points make a line. Why would you do 3? Madison, any idea? Here's the deal. The reason you do 3 is because if I do 2 points, I'm always going to get a line, right?
Yes.
Okay, but if I do 3 points, if I did 2 points and my third point ended up over here,
Write it right back.
then you know you did something wrong, because you are always going to get a straight line. So you do 3 points so that you know for sure you're doing the problem right, because the 3 points all have to be what we say in the math world, collinear, where they form a straight line. So if you're graphing something and you get 1 point here, and you get 1 point here, and you get 1 point there, guess what time it is? it's time to do the problem again because you can't get those points to form a straight line. But if you do the problem and your 3 lines go like this, and like this, guess what time it is?
Line time.
Time to say I'm done with that problem because I did it right.
I did not.
Somebody had a question out there, Madison.
So on our homework, we have to graph, like draw the line.
Yes, if it says to graph the equation, they will call this a function table, that thing we did here. They will say make a function table and graph the line. So you ask what should I see on your paper? Well, you obviously have to write the equation on your paper. You obviously are going to have to do this x and y thing. Get at least 3 points. You get to pick your 3 points. 0, -2, 4, 0, -6, 1, and then you're going to have to graph that equation there, whatever it is, 0, -2, and show your line. So it's kind of a multi-step sort of problem, is it not? But it should make you excited. And then, children, then they might ask you a question like the book says, well, I'll take a look at page, well, let's do one. Let's just do one. Hey, look at page 284. No, maybe they don't ask you. Did they ask you that? If they do ask you to do something somewhere. Where is it? Everybody there?
Letter G.
Liturgy
Letter G.
for this function. Wait, is that you feel like? Thank you for the acknowledgement. Liturgy. No, I'm not so much about that because I already did that one. What about problem number 4 on your homework assignment where it says, shown is the graph of the function y equals 1/2 x plus 3. Does x equals 2 and y equals 4 satisfy this function? So what you would do for that problem is this. What was the equation? Was y equals what?
1/2 x plus 3.
Wow, 1/2 x plus 3. And they did the graph of it, right? It doesn't tell you the graph of it. They do show you the graph of it, which looks a little like this. Somewhere there's a dot here and there's a dot here. And you have this line here. And they ask you a question, does, what's it say? Does what? X equals 2, y equals 4. X equals 2, y equals 4. Does that work with this equation? Well, basically what they're asking you to do is this. First of all, this point should be on your graph. Is the point 2, 4? And I don't know if mine is 1, 2, 1, 2, 3, 4. It looks like it is. Is the point 2, 4 on that? That's one way to look. And the second way they said is put this in for x. If you put 2 in for x, will you get 4 for y? What's half of 2?
1,
What's 1 plus 3?
4.
And if that works, then yes, this is one of the solutions to this equation or that function, if you will. Is that not exciting to anybody but me? Well, which way would you answer that? No, I don't.